Notes 10.2. Welcome to Notes 10.2. We're going to look at two major objectives today, and we're going to do some calculations to figure out pH and to figure out concentrations of ions. So there's a bonus opportunity. Please look at Chapter 19, Section 19.2. Also look at the page numbers and diagrams or figures listed below. Put all that in your notes, okay? And then you'll write it on the quiz. Okay, so water's wet. Yay, look at that pretty picture. All right. So what's in water? Well, we know we got the H2O. We also have some H plus, and we also have some OH minus. Hard to believe, but true. So if we have H2O and it bumps into another H2O molecule, then, of course, it's going to always bump back. You're going to get H3O plus and OH minus, because when they bump into each other, one of the H's can transfer to the other water molecule. Of course, this is an equilibrium, and the equilibrium, I shouldn't have made that arrow that big. It should be a really small arrow going forward and a really big arrow going backward, okay? So that means when you have water, you have some of everything because it's equilibrium. Remember, H3O plus is another way of writing H plus, right? So I could rewrite this equation as H2O, mostly H2O, tiny bit of H plus, and OH minus. Okay, this is water's equilibrium. This is the reality of water. And so every time you get one of these, you get one of those. So every time you get an H plus, you get an OH minus. And so they equal each other because they're coming from a water molecule. That's why water is a balance of OH minus and H plus, hydroxide and hydrogen ion. And so water's neutral because there's equal amounts of those. So pH is a way to relate to the molarity of the hydrogen ions in the solution. Okay. So remember, capital M is molarity, and it gets plugged into the brackets all the time. The molarity gets plugged into the brackets. So if you want to know the pH of a solution, then you just have to take the opposite log of the concentration of the hydrogen ions. Well, let's look at water. If we take the opposite log of the hydrogen ions, because I tell you that the equilibrium for this, the hydrogen concentration and the hydroxide concentration always equal 1 times 10 to the negative 14. That's what it's been measured to be. If you multiply those two things together, you get 1 times 10 to the negative 14. Well, you know this must be 1 times 10 to the negative 7, and this must be 1 times 10 to the negative 7. So if we take the pH of water, we'd say negative log of 1 times 10 to the negative 7. And you hit that on your calculator, the negative button, the log button, plug that in, you get 7. So the pH of water is 7. Woohoo! That means the pOH of water is also 7, and when you add them together, you get 14. So what does that mean? Well, let's talk about, that's for water. Now we're going to talk about acids. So how do I know the concentration of hydrogen in an acid? Well, we're going to look at strong acids for this only. If it's a strong acid, then the H plus concentration equals the concentration of strong acid. Why? Because remember, strong means it breaks up totally. So if I have one of these 6 acids, right, and I'm given the molarity of it, then I automatically know the concentration of H plus. So let's see. What is the pH? So we're trying to find, hey, what's your pH? Given H plus HCl concentration, right? Concentration of HCl. But what we know, since this is strong, every time we get an HCl, we get really the same amount of H plus. Because it's a strong acid, you know, the H plus concentration is 0.1 molar. So how do we get the pH? Well, here's a little diagram. I know the H plus concentration, and I want pH, so I just follow this arrow, and it says take the negative log of 0.1. And when I plug that into my calculator, I get a pH of 1. Okay. It says, what is the pH? That's what we're looking for, of 0.015 molar HNO3. Okay, step 1, hello, it's an acid. Step 2, it's a strong acid. So that means that the concentration of HNO3 equals the concentration of H plus. So we know the H plus concentration. And so we need to find the pH, so we have to take the negative log of 0.015. and you plug in the negative sign on your calculator, you hit the log button, you plug in 0.015, hit enter, you find out that the pH of this solution is 1.82. Okay? So in order to find pH, you just have to take the negative log of the hydrogen concentration. For strong acids, if you know the concentration of the acid and you know it's strong, then you also know the H plus because all of it turns into H plus. So this diamond is going to help us. We were at this place. We were given this, and we were asked to find pH. So if I follow this arrow, it gives me the formula for calculating pH. So that's what I have to take that number, plug it in there, and hit those buttons on the calculator. And boom, I get the pH. So what does this pH stuff mean? All right. Well, if something has a pH of 0, it's things like battery acid. pH 1, that's your stomach acid. pH 2, lemon juice. There's some lemon juice. All right, so here's the other pHs. If you notice, a pH of 7 is water. Okay. Your saliva is actually a little bit acidic. Seawater is actually a little bit basic. Okay. And here are the bases. Bleach is up there really high on the pH scale. It's a number on the 13 on the pH scale. Drain cleaner is 14 on the pH scale. So these things down here have a lot of H plus. These things up here don't have a lot of H plus because they have more OH minus. So just because I know you guys are interested in all of that sour candy, right? So here's your pH 7. Okay, you got some water. But if you notice on here, some of these candies are acidic. Get the pH. Now you start losing your tooth enamel at a pH of 4. Starts dissolving your tooth enamel. So substances that are pH 4 or lower are going to dissolve. Look, and here's battery acid. So when you eat the Warhead sour spray, wow. Not sure you want to do that, but if it tastes good and you rinse your mouth out, it won't eat away your tooth enamel too quickly. Okay? All right, so why do we use pH? So pH scale was developed because it's a little bit easier to talk about numbers 1 to 14 than it is to talk about the real concentrations, like 1.4 times 10 to the negative 10. Right? It's a small number. It's a little bit hard to work with. It means 0.00000060789. Right? So this number right here means this number. 1, 2, 3, 4, 5, 6, 7, 8, 9. And that's where the negative 10th comes from. So this is a really, really small number. So instead of using really small numbers like this, pH helps make things easier. Okay. So if you have a pH scale, you're worried about the hydrogen concentration, then you have a pOH scale, which is the opposite of it. Okay. So instead of worrying about the hydrogen concentration, you're worried about the hydroxide concentration. So as the pH of a solution goes up, the pOH of a solution goes down. They're opposite of each other. Okay. And so, same calculation. If you want to know the pOH, you have to take the opposite log. But because it's OH, you have to plug in the hydroxide concentration. There's a relationship between pH and pOH, and it's 14 if you add them together. Right. So how do you know hydroxide concentration for that? Well, if you have a strong base, it breaks up totally, you have the hydroxide concentration. Strong bases come from group 1 and 2 hydroxides. Oh yeah, right? So this one's saying, what is the pOH of a 0.022 molar NaOH solution? So here's the NaOH concentration, right? But it also equals the OH minus concentration because all of this turns into hydroxide. So then, if we want pOH, so we know the hydroxide, we want pOH, we got to take the opposite log of 0.022. When you take the opposite log of 0.022, you get pOH equals 1.66. But what does that mean? That means that on the pOH scale, it's 1.66. But we don't talk about the pOH scale, we talked about the pH scale. So, yes, we were able to get the pOH, but really we want to look at the pH to know what it means. So then, now that we know the pOH, we know this, we want pH, we have to go this way. Look, the arrow points are supposed to say 14 minus the 1.66 that you got for pOH is going to give us 12.34. All right, so this tells us more about it. We know this is basic. because the pH is a higher number, or it's closer to 14, and that's what bases are, above 7. Okay. So what is the pOH of 0.001 molar lithium hydroxide? Okay, so this is a base. How do you know? Oh yeah, it's a base. It's a strong or weak? Strong because it's got lithium metal in it. So the concentration of the LiOH is equal to the concentration of hydroxide, because guess what? Strong means all of this turns into that. It all breaks up into hydroxide. So now that we know that, we can say, well, pOH, so we know OH, we need pOH, we're going to take the opposite log of 0.0001. Right, so I plug that in my calculator, and I find out that the pOH equals 4. All right, well, what does that mean? But I don't really know what it means until I convert it to the pH scale. So now that I know pOH, then I could turn it into pH by saying 14 minus it. So 14 minus 4 gives me pH of 10. pH of 10 means basic because anything above 7 is basic. Okay? Which makes sense because guess what? We're working with bases here. And so the pH should show a basic solution. All right, now you can calculate any of these 4 things around the diamond. And you're going to have to be able to do that. But there's formulas to help you. All right. So this one says, what is H plus? That's what I'm looking for. This is what I am given. This is what I know. Okay. So I know the pH, so I know this. What am I trying to find? H plus. So which formula do I use? Well, follow the arrow. I find out that I have to find H plus, I have to take 10 to the negative pH. So H plus equals 10 to the negative 2.3 exponent. So when I plug that in my calculator, I get 0.00501. Now this is the concentration that's molar. But that means 5.01 times 10 to the negative third molar. Okay? So that's how much hydrogen ion is in a solution with a pH of 2.3. This question says, what is the OH minus? Okay, so I'm looking for OH minus. What do I know? I know pOH. So it's one step, and I just follow the arrow, put it to there. So if I want OH minus, I need to use 10 to the negative 11.1 to figure it out. So I plug in my calculator 10. I hit the caret button because I need to do this in exponent. Hit the negative button 11.1, and I find out the hydroxide concentration is, now this is going to show up on your calculator, and you're going to have to look at the end of the number, 7.94 times 10 to the negative 12 molar. Anytime your answer is for the brackets, you have to put a capital M on it because it's the concentration. Okay, so that's not very much hydroxide ion, right? All right, now this next question says, what is the H plus? And I'm given pOH. All right, so I'm given pOH, I'm here, but I want to find H plus. So I got to go 2 steps around the diamond. I'm like, all right. So if I want, well, I could go up or I could go down. But I think going this way would be easier because this says if I know pOH, I could find pH by saying 14 minus 9.4 equals 4.6. 4.6. But I'm not done because I didn't want to stop at pH. I want to keep going to H plus. So of course I probably should erase that. If I know pH and I want to know H plus, I got to do negative log of H plus. So I already know pH. Oh wait, I got to follow the arrow. Look, the arrow points that way. So to find H plus, I do 10 to the negative 4.6. So in your calculator, put in the number 10. Then you hit the caret button to get an exponent, and then you put the negative sign, then 4.6. So when I plug that in the calculator, I get 0.000025 molar. That's a long number to write out. So scientific notation will give us 2.5 times 10 to the negative 1, 2, 3, 4, 5. Negative fifth molar. Okay? So make sure you can write it either way. All right, let's see what else we got going on. Hey, look, it's the diamond again. But I just wanted you to make some connections here. Because all acid-base reactions that we're going to do are going to be done in water, the H hydrogen ion times the hydroxide ion is always going to give us a constant, 1 times 10 to the negative 14th, because it's in water. Okay, so that's this formula here. So in order to keep this number the same, if this goes down, that has to go up. But what if this goes down? That has to go up. So as one of these concentration goes up, the other goes down. Well, if this is going up, then guess what? It's being it's acidic. If this goes up, it's basic. So as H plus goes up, OH minus goes down. Right? So if the H plus is 1 times 10 to the negative 6, what is the OH minus? So I already know the H plus, so I'm here. What do I want to get to? I want to get to OH minus. One step, I could go right there. I have to follow the arrow that way. So hydroxide ion concentration is going to be equal to 1 times 10 to the negative 14 divided by 1 times 10 to the negative 6. So I knew the H plus, so I plugged it in at the bottom. This is going to give me 1 times 10 to the negative 8 molar. So it has to equal this. This is to the 10 to the 6th. This is 10. So this is 10 to the 14th. So that has to be 10 to the negative 8 molar. 10 to the negative. So these are all small concentrations. If I wrote them out, it'd be 0.0000. Okay, next question. If I already know the pOH is 6.77, I want to find the H plus. So I'm looking for H plus, and I know given pOH. So I got this one. What am I trying to find? I'm trying to find H plus. So I have to go up and around, or I have to go down and over. All right. So I'm going to go. Let's see. This time I'm going to go down and over. All right. Now you can pick either direction. All right. And so I picked the direction I'm going down and over because I like the number 14. So first I'm going to find pH by saying 14 minus 6.77 is the 7.23. So the pH is 7.23. How did I get that? Well, I was given pOH. I follow this arrow to get pH. But I'm not done because I want H plus. So now if I want H plus, I have to do hydrogen ion concentration. It's going to be 10 to the negative 7.23. And that gives me a small number, 5.29 times 10 to the negative 8 molar. Okay? So you're going to use this diamond to get around. Given one of the 4 things on there, you should be able to get to any of the other ones. All right. So just so you know, H plus and OH minus, if this were even Steven, then it'd be at 7, right? It'd be at 7 because you'd have equal amounts of H plus and OH minus, which give you a pH of 7. If you have a pH of 1, that means you have a lot of hydrogen concentration, lots. pH of 1, lots of this. All right? So that's when you have a pH of 1. Okay? pH of 14, lots of this. And then if you even it out, as you get less H plus, you get more OH minus till you're perfectly even at 7. All right, pH scale. How acidy is your acid and how basey is your base. All right. We looked at this already. This is a new one, tomato. Tomato is about 4 on the pH scale. Milk's a little bit basic. A little bit acidic. What's interesting about the milk is it changes over time, right? Its pH is going to change. When if you get sour milk, the pH is going to go down that way. The sour is going to turn acidic as it spoils. All right, so pH of 7 is neutral, doesn't hurt, unless it's salt water getting in a cut, that might be, but it's just water. Extreme pHs are dangerous, either end. pH 1 is dangerous, pH 14 is dangerous. pH of 14 is lye, it's called lye. It's concentrated NaOH. And yeah, it's been used to do some not so nice things. pH of 1 would dissolve your teeth in days, and then pH of 7.4. Your blood actually has a pH of about that, right? And I guess it makes us happy like a vampire. Okay, so just to review, you should be able to calculate any of these 4 things given one other one. So if you're given pOH, it's 1 step to get hydroxide concentration. Given this, 1 step to get pOH. But if you're given H plus and you want pOH, you're going to have to do 2. Okay, so you might have to do 2 steps around the diamond, one step around the diamond, we'll be practicing. All right, so just to review, how do you recognize an acid? Hello, I'm friendly, and you can have my H+. These are the 4 formulas, really, that we're doing going around the diamond. Okay? So water is in equilibrium, so as one thing goes up, the other goes down. Hydrogen goes up, it's getting acidic, and that's less hydroxide. Hydroxide goes up, it's getting basic, and that's less hydrogen. All right, again, bonus opportunity. Please take it and use it and learn a lot. Peace out from Harbs. Oh, hey, there's our bullet points again. Okay, for real now. Bye.